Hi, I'm Sandra Magnus, member of the Expedition 18 crew aboard the International Space Station, and I'd like to welcome you on board our lovely station. We're going to talk a little bit today about what it takes to build a space station and all the busy work we've been doing up here since I arrived 4 months ago. It's been quite an adventure. You know, the station first started 10 years ago with the orbit of the first piece out of Russia. And ever since then, we've been building the station and improving it and renovating it and making it bigger. And it was part of the plan, of course, from the very beginning, because you can't launch something this large as one structure. And so you have to launch it as pieces and construct it in space. So it started with one small module that was maybe 40 feet long, maybe 20 feet in diameter. And today we have the equivalent of a 3-bedroom house up here. It's 15,000 cubic meters. Of course, when you think of your house, you think of square meters because you're pretty much confined to the floor. But here on the space station, we think in cubic meters because we can move around in 3 dimensions, like this. And so I can turn around and I can spend just as much time on the ceiling as I spend on the floor. And so we have volume up here that's much greater than an equivalent volume that you have in your house, because we can use that 3rd dimension. So it's actually quite a large structure, and it's both a home and a laboratory for us. It's about the size of a football field from end to end, and about the same size width to width. All of the modules that we live in are along the axis for the most part. And we have this huge truss outside that has our solar arrays and some of our external equipment. You know, we're flying around about 240 miles above the Earth at 17,500 miles per hour. And we're up here living and working in space and learning a lot about this environment and how people behave in this environment and how equipment behaves in this environment, and also learning things that help us move technology forward and further our ambitions to go to the moon and Mars. As I mentioned, we started building this piece by piece by piece, and pieces have been launching both out of the US and out of Russia. And then we've been putting them together here. So as an astronaut, I'm actually sort of a construction worker in an exotic environment. I have to learn to be an electrician and a plumber and do all kinds of things that you might need to repair your own house or do projects on your own house, because that's basically what we're doing up here, with the added complication or fun factor, if you will, of being in zero gravity. These are the Human Research Facility racks. And these are the racks which I interact with as a guinea pig, if you will. You know, all astronauts are guinea pigs. We sign up to participate in many different kinds of medical experiments because that's one of the things we're trying to understand is, well, how does the human body react to microgravity? And of course, when we go to the moon, we're going to learn new things about living in 1/6 gravity, and later when we go to Mars, about 1/3 gravity. But it all starts here in microgravity, because this is sort of the extreme. We go from 1 to 6 orders of magnitude less, and then we're going to try and live in these environments that are somewhere in between. So this is a very good data point for trying to understand, you know, the magnitude of the possible changes that we can see in the human body. In this rack, there's a refrigerated centrifuge, and the purpose of this centrifuge, unlike the one in the Japanese segment, this is strictly to process blood and urine specimens and get them ready to go into that freezer for conservation before returning to the ground. And so this is a very important piece of equipment. Also over here we have gas analyzers and different places you can plug in bottles. And we use this gas analyzer system, and there's sort of an elaborate setup that comes off of this rack, and that's to study cardiovascular behavior. You know, how is our oxygen processing working? How is our metabolism changing? Are we losing any cardiovascular capabilities while we're here? It's well known that, you know, you have a little bit of a dip, and with exercise you can bring it back up. Can you bring it all the way back up? You know, what are the changes? There's so much about what happens to the human body that we really don't understand. You know, our immune systems get depressed up here. We really don't understand why. If we can understand that mechanism, perhaps that knowledge can be used directly to help people with similar problems, you know, diseases that affect the immune system on Earth. I'm sure you're all very aware of the fact that we lose minerals out of our bones while we're up here, and a very strong exercise regime can take care of that or mitigate that a little bit. We're still trying to understand why. You know, it'll help people with osteoporosis on the ground if we can understand the fundamental mechanism. So we're pretty big guinea pigs up here for all these things. And this is one of the facilities that we use to interact with, to gather data and do the experiments, you know, on ourselves. It's very, very interesting. And let me show you the other rack real quick as well. This is the other HR, Human Research Facility rack, number 2. And what's really nice about this rack is it has an ultrasound machine in it and also a body mass measurement device. And of course, keeping track of your body mass is very important because you're trying to determine whether or not you're losing weight and how much weight you lose. It's been established that if you lose a lot of weight in orbit, you're losing muscle and not fat. So it's really not good to try and lose weight up here. The ultrasound's been proving very interesting because we've been trying to study changes in blood flow with potential countermeasures. You know, as we live here in space, our hearts and our vascular system does not have to work so strongly against gravity, and so they kind of, I don't want to say get lazy, but certainly they don't need to work as hard. And so there's different experiments that we do to study using the ultrasound, actually, how the blood flow in our veins change with different kinds of loading, if you will. If we wrap a plastic band around our leg, how does that affect the blood flow? And that would be different than how it would be on Earth because the blood pressure is a little bit different and that extra force of gravity is not there. And so we can do that. At the same time, we're proving out some very interesting telemedicine techniques because, of course, we get some training on the ultrasound, but we're far from being experts in ultrasound technology. And when we do these experiments on ourselves, we're in contact with some experts on the ground who walk us through the procedures on how to get the ultrasound pictures that the experimenters need to interpret the data. And so you have a very good model here for how we might be able to implement some telemedicine, and we can take that information and feed that into the similar systems that are being developed around the world to bring healthcare to people in very remote places. So there's another good example of a synergy between science that we're doing on station to advance our knowledge, as well as a technology development program that can be used to help people on Earth.